think the best thing for you to do is to start getting a bit of familiarity with this particular risking spreadsheet. And in the end, I think it's a thing that, again, as I said, I think that everyone should be comfortable with using personally, and it really needs to be a sort of a cooperative or a common ownership that both the asset team members and specialists, geologists and geophysicists all have ownership of and believe in the results sort of coming out. Let's go into exercise 6. If you go and take a look at the risk analysis, that what I've gone, I've highlighted here only the things you need to fill in as yellow. The other things have been set for you. I give you the information in words. It's kind of a little story problem. You need to figure out sort of where from that little exposition these numbers come from to put in there. If you go in and you can, there are different parts of this. You can go and you want to take a look at both, first of all, the seismic inputs. This is where you have the little slider bars to set the different data quality stuff. And I encourage you to play around with it, but you're told the information you need to fill that out. I think that we asked what was your observed reflection coefficient from an earlier exercise in order to go in here. You need to go and fill that out. Going and taking a look at, I think there's a particular cross-section there for you to take a look at in terms what is the potential fit to structure here and the nature of the contact. And so that's put out there for you to take a look at. And sort of based on that, you'll want to come back into, the risking spreadsheet and go into the structural inputs and decide where you would want to put this. And then if you go to the, the uplift summary, you can then take a look at what happens to your probabilities. You can turn on the seismic reflection strength, turn on and off the structural evidence. And if you want to take a little bit more look at the calculations, you can go in here and it sort of shows how the calculations get done here. The priors, if you click here, you can actually see the formulas for how we divide up the geologic risks into each one of these. And yeah, you probably see bug farts here, but anyways, that has to do with biogas. And I also go and talk about gas which fits and doesn't fit structure. And that has to do with the fact that low sat gas many times won't fit structure. And so we actually do explicitly bring that in and allow that to be sort of extra boosted. But certain low sat gas we do allow to fit structure, and that tends to be stuff associated with blown traps. And if you take a look at the probabilities, that actually says the trap has to be blown in order for, the seal has to be blown in order to have sort of low sat gas that fits structure. Other low sat gas does not fit structure. Anyways, sort of welcome you, sort of going in, following the things for exercise number 6, and sort of risking this one prospect. I'll go and.
Because you have a, that's a called a function reservoir.
That's a good question, actually.
Who's the conference?
Is there a way in this way you can just take out the
accident ratio is 4.7.
but is there some flexibility in it?
That you have to go and no, you have to go. This is really locked up with the geologic priors purposefully. You can go and take it out as a case, or make it, just move the hump sort of out of the range of possibility.
Because if there's an overlying, like the hump graph in the background that you're saying is based on physiology, then you can remove all the hump, remove the shell one, so it's all sand.
Yeah, but again, Yeah, well, again, we tried to go and in here really link things to geologic probabilities, especially in this spreadsheet. It's probably easier to do that in actually the amplitude spreadsheet where they can a couple of things that if you ended up going and sort of playing around with, that if you go and turn off sort of both of the pieces of evidence, you see that they end up being equal. Structural evidence, you can see sort of how much that just comes about from the structure. And then if I click here, you can see how much is sort of added, according to the reflection strength. And many times we do this to sort of understand sort of what's determining what and where, and how strong each one of the boosts are. There was a kind of an interesting thing that Mark was pointing out, and that has to do if you come into the seismic area, and this is pretty close to what you would expect for oil, but if you ended up having something that was sort of closer to the gas value and went back to the summary page, you end up seeing, not surprisingly, the large oil slice has been replaced with a large gas slice. And this is kind of the thing that I think I just got done talking a bit with Mark about, is that if you come in here and put in the most likely value for brine, which is 1, that you end up finding that if I go to the uplift summary, that, well, brine increases a little bit, but not very much, okay? And, well, let me just turn off the particular structural evidence. Maybe it goes there if we sort of ignore structural evidence, that you end up seeing that it actually increases a bit more, okay? But so you have to understand that the structural evidence argues against brine and will tend to bring things back, so that, again, if you take a look at brine goes from 33 to 25% based on structural evidence, so that backs it off. But just on the reflection strength, it takes it up from 33 to 47%. But you have to, again, realize there's quite a bit of overlap down here. And it's hard to find a particular amplitude that's brine only, since it's sitting between shale and oil, and there's a fairly significant overlap of both of them with brine, okay? And but again, it just sort of comes out in the math and the fact that brine is sitting right next to some neighbors that you can confuse it with. Another thing, let me go back and set the seismic back to about the 2.3. Most likely value for oil. Then also, if you started playing around with this and said that we ended up going down to spec 3D, notice the confidence goes down to about 40% from the, close to sort of 75%. And so there's a fairly, significant influence on that. And in fact, if you want to see the formula, you can just click on here in order to see. It's a fairly straightforward sort of linear combination, or close to linear combination of things, and never allowing it to get greater than about 9% or sort of less than a few percent.
So it's not equal for all, like you bring the well data down to a few wells, you drop as much?
No, you don't.
Okay. It's not equal for each.
Yeah, and it really is sort of saying that well information sort of extrapolates modestly well, and you can see that we brought all the well information down, but we're still at 50, okay, or 60 is kind of the maximum. But it doesn't take much to really start doing. These things are all fairly powerful functions of both the quality of the seismic data as well as the type of seismic data that you end up having. And it ends up being an and, because either of these being poor ends up decreasing it, because it's poor quality data, and even though you tried everything, if you can't see anything, you'll have issues. And also, if you haven't taken care of stuff, you're not going to be able to go and get very much either. And it's really from the viewpoint that if you go and don't process this correctly, those amplitudes really can mean very little. And that's the reason why we've had fairly large and associated with both of these things, where with the well data, it ends up being a more modest difference as you sort of decrease the quality of your knowledge. But again, I think it's representative of the quality of sort of global relationships with many of the well information that we end up having.
So Mike, just on the ratios, where would you pull your 4.6 ratio for gas or your 2 point whatever ratio for oil? I mean, would this be quite happy for us to get out there on rave, or would you go into the earlier exercise today where we did a loop around what we thought was a gas leg in the MATLAB tool?
Yeah, well, I mean, you have to remember that you want to have amplitudes that are sort of above tuning thickness, okay? If you can go into rave and isolate amplitudes that are greater than tuning thickness in the area that you're interested in and get an average value, that's perfectly okay. We've explicitly put that into this workflow of where we go and we mask out things that are below tuning thickness and then allow you to go and circle another area. So going and using rate values are fine, but keep in mind what you need to choose, okay? Don't grab points that are at or below tuning thickness when you're going to be doing this. And whatever lassoing program you have, go ahead. The nice thing about this is that it does have that masking. It's integrated with the secant, and it also has those Bayesian probability maps that a lot of people like seeing too, that you get as part of the process. And also it's easy to take sort of these arbitrary lineouts. But you know, again, just understand what you really want to do, and you find equivalents in other areas that really do the same stuff. I mean, that's perfectly fine. So this just defines what the workflow and what the thought process is, and you can go through the boxes and you do the things that you should. I think you'll find, though, that some of the stuff with respect to the AVO normalization that we're about ready to get into is much harder to sort of reproduce in some of those processes. So in terms of some of these rotations, I think you could do it, but you're going to be fiddling around quite a bit, and it's going to be harder to do a step-by-step through the workflow associated with it. But I've never been, a particular, hopefully people don't have a perception of me being very dogmatic that these are the only ways to do things. We just try to have tools to help you through the workflow and to help document the workflows. Okay. We're into the last lecture for today, and after this you'll be getting into exercise 7. This is the AVO. Unfortunately, we've gotten into AVO at the end of the day, and I realized, I think both I started slowing down, it was off my game, and I think everyone else's sort of absorption rate ended up being a bit lower yesterday. But hopefully we can get started on this, and we'll continue it through tomorrow morning, and hopefully people come in maybe with a fresh mind then too, and sort of absorb what's going on with respect to the AVO. But let me go, and I'm going to talk a bit about and sort of show you the example you're going to go through, and also talk a little bit about sort of wavelet derivation and some of these calibrations, okay? Well, it's good to project what I need on the screen, isn't it?